Let's talk about how we can use the law of sines and the law of cosines to calculate missing angle measures and side lengths in non-right triangles. So far this unit we've learned that you can only use trigonometry for right triangles, but that's not completely true. Creative application of similar triangles yields two formulas that allow us to calculate the missing side lengths and missing angle measures even if it's a non-right triangle. These formulas are called the law of sines and the law of cosines. The law of sines is this proportion, which is just three ratios comparing a side length to the sine of the opposite angle. So A over A equals B over B equals C over C. The way it's written here has all of the side lengths on top and the sines of each of the angles on the bottom. Sometimes you'll see this formula written upside down, and that's totally fine. It doesn't matter whether you have side lengths on top and angles on bottom, or vice versa, as long as you're consistent. All sides go on top and all angles go on bottom, or all angles go on top and all sides go on bottom. It's also important that you're comparing a side length to its opposite angle each time. It should be A over A, B over B, and C over C. We can only use the law of sines if we're given certain information. If you're given two angles and a non-included side, that's AAS, or two angles and the included side, ASA. Or if you're given one angle and two sides, but the angle has to be non-included between those two sides, which is SSA. You might remember these combinations of letters from when we learned about triangle congruence. And you might be saying right now that, wait a second, you told me that we can't use SSA or ASS. And that's true if you're trying to prove that two triangles are congruent to each other. But that's not what we're doing today. Today we're looking at just one triangle and figuring out its missing angle measures and its missing side lengths using trigonometry. So SSA, if you have that situation, it's totally fine. However, we'll learn in our next video that this one is a little bit more complicated than the other two, because there may be one answer, two answers, or no answers. That's called the ambiguous case, and we'll discuss that in depth in our next lesson. If you're given a different set of information about the triangle, then you'll need to use the law of cosines. There's two ways to write the law of cosines depending on whether you have side lengths or angle measures. If you're trying to solve for a side length, use this version of the formula. And if you're trying to solve for an angle measure, use this version of the formula. These two formulas are the exact same thing, they've just been solved for a different variable. In the first version, we're solved for little a squared, and for the second version, we're solved for the cosine of big A. So again, it all depends on which thing you're solving for. If you want to solve for a side length, do little a squared equals the rest. If you're trying to solve for an angle measure, do the cosine of big A equals the rest. You can only use the law of cosines if it's a side angle side or a side 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 case. So if you're given two side lengths and the included angle, SAS, or if you're just given all three side lengths but no angles, SSS, then you can use the law of cosines. One small note to make about solving a side-side-side case, you do have to start by calculating the angle that's across from the longest side in order to ensure that you actually get the correct answers. So let's take a look at an example. The first thing you need to do every time is identify what kind of information you were given. That way you can determine which law to use. Here I see that we've been given two angles and a non-included side. So that's an angle-angle side case. An angle-angle side can be solved using the law of sines. The formula for the law of sines has a total of three ratios in the proportion, but when you're solving, you really only need to pick two at a time. You'll pick one that's complete and one that has a variable that you're trying to solve for. You don't need to write all three of these ratios in order to solve. So to get started, you need to identify which ratio would be complete. In other words, look for a pair of a side and an angle that's opposite from that side that you know both parts of. And in this case, that's angle A and side length BC, which we could also call side length little a, uncapitalized A. I know that the length of this side is 6 miles, and I know that the angle opposite from that side is 108 degrees. So the first ratio that I'm going to write is 6 over the sine of 108. Then I'll set that equal to a ratio that has a variable in it, as well as some information that was given on the diagram. In this case, that's angle B, and the side across from that, which is called AC. So side lengths for us go on top, angles go on bottom, so the side length is going to be my variable. AC is going to go on top, and then the sine of the angle that's opposite from AC goes on the bottom. So now that I've set up my proportion, I can cross multiply and solve. So I get 6 times sine of 35 is equal to AC times sine of 108. Divide both sides by the sine of 108, and we find that the length of AC is 3.6 miles. Next up, we need to solve for the length of AB. But in order to do that, we need to know the measure of the angle that's opposite from that side. We need to know the measure of angle C. Thankfully, that's actually pretty easy to calculate. We don't even need trigonometry to do it. Since this is a triangle, and I know 2 of my 3 angle measurements, I can just add all 3 together and solve for the missing angle. The measure of angle C must be 37 degrees. Now I can write a proportion that's similar to the proportion we started with for AC. I'll start out with 6 over sine of 108. That was the side and the angle opposite from that side that we already knew both parts of. And this time I'll set it equal to AB over the sine of 37. Then, just like solving for AC, we can cross multiply and divide by the sine of 108, and we find out that AB is 3.8 miles long. Let's try another one. This time we've been given 2 angles, and the included side. 19 is the side that connects those 2 angles, so this is an angle side angle situation, which means again we need to use the law of sines. One of the ratios that you'll set up when you're writing the law of sines is the angle and the side opposite from that angle that you know both measurements of. But this time we weren't given something like that. Opposite from 124 is AC, and I don't know that length. Opposite from 20 is AB, and I don't know that length. And opposite from side BC is angle A, but I don't know that measure. The good news is we could figure out the measure of angle A really easily. So let's go ahead and add all 3 of those angles together and set it equal to 180. And now that we know that the measure of angle A is 36 degrees, I can go ahead and set up the law of sines. The first ratio I'll write is the complete one, 19 inches, over the sine of 36, because that's the side and the angle opposite from that side that I know both measurements of. Now it's really just a personal preference on which one you want to solve for first. Let's say, for example, you wanted to solve for the length of AC first. Well, the angle that's opposite from AC is 124. So the ratio that I'll write is AC over sine of 124. So I'll cross multiply, divide both sides by the sine of 36, and I find out that the length of AC is 26.8 inches. And I can do basically the same thing to figure out the length of AB. I'll set up that first ratio that was complete, 19 inches over sine of 36 degrees, and this time set it equal to AB over the sine of 20. Cross multiply, divide by sine of 36, and I find out that AB is 11.1 inches. For our next example, we're given 2 side lengths and the included angle measure. So it's a side angle side situation, which means this time I need to use the law of cosines. I recommend labeling your sides with A and B and C to get started with. That'll make filling in your law of cosines formula a little bit easier. I labeled each of these sides with the lowercase version of the angle that's across from it. So this is capitalized A across from that angle. I'll call that side length little a, and then same thing for B and for C. Remember that there's 2 versions of the law of cosines depending on which thing you're trying to solve for. To determine which thing you're trying to solve for, look at which thing do you know. Do I know little a or do I know big A? Well, looks like we know big A. The measure of angle A is 53 degrees, so that must mean that we're looking for the length of little a. So we're going to use the formula little a squared equals little b squared plus little c squared minus 2 times little b times little c times cosine of big A. So if we fill in that formula, we get little a squared equals little b squared, so 28 squared, plus little c squared, 35 squared, minus 2 times little b times little c times cosine of big A. And when you look at the right-hand side of this equation, I know it looks really scary because, oh my god, so many numbers. But that's just it. They're just numbers and a cosine. You can type literally this entire string of numbers and addition and subtraction and multiplication. Type this whole thing into the calculator. and you'll end up with 829 point stuff. But that's not the length of little a. That's what a squared equals. So you're not done yet here. In fact, look at the diagram. Would that even make sense to have one side that's 28 and one side that's 35, and this side somehow equals 829? No, of course not. So make sure you do that one final step of square rooting both sides to get a final answer of CB equals 28.8, which is a much more reasonable answer in comparison to the other two sides. So now I know all three side lengths, but I'm still missing two angle measures. At this point in the process, we can actually use the law of sines to solve, because at this point we know one ratio that's complete. We know the measure of angle A, and we now know little a. We know the side across from angle A is 28.8 meters. So let's go ahead and write that as the first ratio in our law of sines formula. The side length we calculated was 28.8 over sine of 53. Now notice I left this ... on there. That's because you really should not round in the solving process for law of sines and law of cosines. It's okay to round your final answers, but if you use that answer again later in a different formula, you need to be using the entire decimal, 28.80004, yada yada yada. So just don't clear that out of your calculator. Keep using that number as you do the rest of the calculations. So this was our complete ratio. Now I need to set it equal to either something that would solve for the measure of angle B or the measure of angle C. It doesn't matter which one you solve for first. Let's say I wanted to solve for the measure of angle B. The side opposite from angle B is 28 meters. So I'll write 28 over sine of B. Cross multiply and divide both sides by that 28.80004 yada yada. You need to be dividing 28 times sine of 53 by the entire decimal to get this decimal. This is not your angle measure. It wouldn't make any sense to have an angle measure of 0.7764 degrees. That would be a teeny tiny little angle, and B is obviously not that small. This is not your answer because it's the sign of your answer. To solve an equation that looks like this, we need to use inverse sine. So take the inverse sine of this answer, and you get an answer of 50.9 degrees. You could use the law of sines again to calculate the third angle measure, but at this point we know two of the three angle measurements. We know that angle A is 53 and angle B is 50.9, so you can just add all three of those together and set it equal to 180, and we find out that the measure of angle C is 76.1 degrees. For our final example in this video, we have a side-side-side situation. I know all three side measurements, but I don't know any of the angle measurements. Since it's SSS, we'll use the law of cosines. Remember that there's two versions of the law of cosines depending on which thing you're looking for. In this case, I know the length of little a. Little a is across from big A, and this is little b and this is little c. I know the length of little a, but I don't know the measure of big A. So the version of the formula that I need to use is cosine of big A is equal to little a squared minus little b squared minus little c squared over -2 times little b times little c. So let's fill that out. Cosine of big A equals little a squared minus little b squared minus little c squared. And I'll put that over -2 times little b times little c. So again, I know this side of my formula looks really intimidating, so many numbers and squares, and oh my god, it's a fraction. But it's nothing but numbers, right? That's why these formulas are written like this, is so that the variable is isolated on one side of the equation, and you can just type this whole thing carefully into the calculator. Make sure that you're putting parentheses around your numerator and parentheses around your denominator when you're typing this in. You should be typing parentheses 121 squared minus 89 squared minus 42 squared, parentheses, divide, parentheses, -2 times 89 times 42, parentheses. If you don't, it'll do some weird stuff where it only divides by -2 and then it multiplies everything by 89 and then multiplies all of that by 42 and you'll get a totally wrong answer. So parentheses are your friend here. But when you type this all in, you should get an answer of -0.6629 yada yada yada. Obviously that's not our angle measurement, we can't have negative angle measures. You need to take the inverse cosine of that number to figure out the actual angle measure. So we find out that the measure of angle A is 131.5 degrees. Now we need to solve for the measure of angle B or the measure of angle C. It doesn't matter which one you solve for first, just take your pick. And to solve for the measure of angle B or the measure of angle C, we're just going to use the law of sines because now we have a complete ratio. I know both little a and big A, so I can write that as my first ratio in my proportion. Again, notice that I have this dot 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 here. That's implying that I'm not just using 131.5. You should not be using the rounded version of each of these answers in your work. It's fine to round your answer when you circle it and say the measure of angle A is this. You can round to the nearest tenth. That's fine. But when you use that number again later on in your work, you need to use the complete decimal. So let's say that I wanted to solve for the measure of angle C. The side that's opposite from angle C is 42 feet, so I'll put 42 over the sine of C. Cross multiply, divide both sides by 121, and I find out that the sine of angle C is 0.2598. And take the inverse sine of both sides, and we find out that the measure of angle C is 15.1 degrees. Now we could use the law of sines again to figure out the measure of angle B, doing basically this exact same process but using 89 over the sine of B instead, cross multiply and solve. But since we now know 2 of the 3 angle measurements in this triangle, we can just add all 3 of them together and set it equal to 180. So we get a final answer for the measure of angle B of 33.4 degrees. And that's all you need to know about solving an angle-angle-side, angle-side-angle, side-angle-side, or side-side-side case using the law of sines and the law of cosines. In our next video, we're going to discuss how to solve a side-side angle situation, which is also called the ambiguous case.